Hello everyone. Ever wondered how your internet works at blazing speeds, or how your microwave heats up food so quickly? While the secret lies in a fascinating technology. Introducing to you Waveguides. Today we will dive into the world of waveguide, exploring what they are, how they work, their application, and why they are essential in our daily life. So let's get started. Waveguides are physical structures designed to direct electromagnetic wave from one point to another. A waveguide is a structure that directs electromagnetic wave from one place to another. It's think of a tunnel that guides cars from one end to the other, but for wave like light, radio, and microwave. By confining the wave within specific boundaries, waveguides ensure that the energy travels efficiently along a designated path without losing much power. So, there are many types of waveguide, which is the circular waveguide, rectangular waveguide, a twist waveguide, and 90-degree elbow. Now, let's talk about theory. So, the most important theory you need to know in waveguide application is the modes of propagation in waveguides. So the mode of propagation meaning that a mode in a waveguide is a specific field distribution pattern that can propagate along the guide without changing shape. So there are several types of modes of propagation in waveguide, which is the first one is transverse electric mode, which is TE. So electric field is entirely transverse to the direction of propagation with no longitudinal electric field component. And for the transverse magnetic mode or TM, magnetic field is entirely transverse to the direction of propagation with no longitudinal magnetic field component. And the transverse electromagnetic mode, which is TEM. Both electric and magnetic fields are transverse to the direction of propagation. TEM modes does not exist in hollow waveguide, but can exist in coaxial cables and dielectric waveguides. So the important thing we need to know is cut-off frequency. So each mode has cut-off frequency below which cannot propagate. For a rectangular waveguide, the transverse electric mode has the lowest cutoff frequency and is often the dominant mode. Moving on, let's dive into the mathematical description of waveguide. The wave equation in a waveguide can be derived from Maxwell's equations, where the separation of variables, by separating the variables, we can solve the wave equation for different geometries such as rectangular or circular. For example, in a rectangular waveguide, we get solution in the form of sinusoidal function that satisfy the boundary condition. And for the characteristic equation, these solutions lead to characteristic equation that determine the allowed mode and their respective cutoff frequencies. Let's discuss about dispersion and attenuation in waveguides. For dispersion, is described how the phase velocity of a wave depends on its frequency. In waveguide, different modes can have different phase velocities leading to dispersion. For instance, for phase velocity is the meaning that the speed at which the phase of the wave propagates given by Vp over equal to omega over beta, where omega is the angular frequency and beta is the propagation constant. And group velocity denoted as Vg, the speed at which the energy or information travels, given by Vg equal to d omega over d beta. For the attenuation refers to the loss of signal strength as it propagates through the waveguide. It can result from material absorption, surface roughness, and radiation losses. The attenuation coefficient alpha quantifies this loss. we can't deny that waveguide played a crucial role in various technologies by efficiently guiding electromagnetic wave from one point to another. Today, we will explore how waveguides are applied across different fields and their significance in modern technology. And the first one is microwave communication system. So, waveguides are extensively used in microwave communication system to transmit signals between components with minimal loss. For instance, satellite communication, waveguides are used to connect transmitters and receivers to antennas in satellite communication system, ensuring efficient signal transmission. Waveguides offer low loss, high power handling capability, and immunity to electromagnetic interference, making them ideal for microwave communication. And for the next one, radar system. Radar systems use waveguide to direct electromagnetic wave towards target and receive the reflected signals. For aviation and air traffic control mostly use waveguide. So radar system in aviation rely on waveguide to monitor aircraft position and ensure safe air traffic management. So, the benefit that we get from the waveguide enable precise control of signal direction and strength, essential for accurate radar measurement and detection. Waveguide also apply to the medical application. Waveguides are used in medical technologies for diagnostic and treatment. For example, MRI machines, magnetic resonance imaging (MRI) machines use waveguide to transmit radio frequency signals to and from the patient, creating detailed image of the body's internal structures. Waveguide will provide high-resolution imaging and precise signal delivery, improving the accuracy and effectiveness of medical diagnostic and treatments. As technology continues to evolve, the role of waveguides will only grow in importance. Advances in materials, design, and manufacturing techniques will further enhance their performance, leading to new applications and improved capabilities in the field, ranging from telecommunication to healthcare and beyond. Understanding the theory and application of waveguide allows us to appreciate the sophisticated engineering behind many devices and systems we rely on daily basis. Waveguides exemplify how fundamental principles of physics are harnessed to solve practical problems and push the boundaries of innovation. I hope you found this exploration of waveguide in electromagnetic wave insightful and information. Thank you and have a great day.